Imagine a world where the most dangerous leftovers of today's nuclear plants become the priceless fuel of tomorrow's clean energy revolution. Sounds like science fiction? A growing chorus of physicists says it's closer than you think. And the secret ingredient is hiding in plain sight inside our stockpiles of nuclear waste. But here's where it gets controversial. Some experts argue that betting on this waste-to-fuel dream could distract us from safer, simpler renewables. Others insist it's the only realistic bridge to a fusion-powered future. Who's right? Let's dig in. The electricity Hunger Games, from the moment you wake up and scroll through your phone to the instant an AI server recommends your next binge watch. Every swipe, click, and stream demands power. Electric cars, cloud computing, and even the humble smart fridge are pushing global electricity demand off the charts. Nuclear fusion, the same process that lights up the sun, promises oceans of carbon-free energy. Yet fusion has a catch-22. Its star fuel, tritium, is scarcer than saffron and pricier than platinum. Enter the plot twist. What if we could mine that tritium from the very waste we're desperate to get rid of? Meet the scientist turning trash into treasure at the American Chemical Society's Fall 2025 meeting. Los Alamos physicist Terence Tarnowsky unveiled computer models showing how still radioactive nuclear waste could be coaxed into producing tritium on an industrial scale. Picture a sleek particle accelerator zapping spent fuel rods, triggering a carefully controlled chain of atom-splitting reactions that spit out neutrons and ultimately fresh tritium. Flip a switch and the reaction stops. No runaway meltdowns, no Fukushima-style nightmares. Why today's reactors can't save us. Right now, our nuclear fleet runs on fission. Uranium or plutonium atoms split, releasing heat and long-lived radioactive junk. That junk, think cesium, strontium, and plutonium isotopes, must be guarded for millennia. Meanwhile, fusion reactors, still experimental, would fuse deuterium and tritium, producing helium and a staggering energy payoff with far less lingering radioactivity. The glitch? Tritium barely exists in nature. The entire planet's inventory is roughly 55 pounds, 25 kilograms, most of it produced as a byproduct in Canadian fission reactors. At $15 million per pound. That's one expensive spark. The math that stunned the audience. Tarnowsky's simulations suggest that a single 1 gigawatt facility, about the annual appetite of 800,000 U.S. homes, could churn out 4.4 pounds, 2 kilograms of tritium every year. That's on par with Canada's entire current output and enough to power 500,000 homes via fusion for 6 months. Even more jaw-dropping. Its design could generate over 10 times more tritium than a fusion reactor of equal thermal power. Translation? Less waste, more bang for your buck. Safety first, headline second. Critics worry that any scheme involving high-level waste is playing with fire. Tarnowsky counters that the accelerator-driven system is inherently safer than conventional reactors because the chain reaction isn't self-sustaining. Shut off the accelerator and the process dies. He's also exploring a molten lithium salt blanket around the waste, a dual-purpose shield that cools the core and locks away materials that could be diverted for weapons. Think of it as a thermos that also doubles as a security guard. The price tag question. Before policymakers sign any checks, Tarnowsky needs to nail down exact costs. He's refining his models to predict everything from neutron leakage to corrosion rates in the salt bath. If the numbers hold, the same tech we use to store waste could become the engine that eliminates it, while fueling the next generation of reactors. And this is the part most people miss. The same accelerator technology could, in theory, be scaled down for regional microreactors or up for city-sized plants. Imagine rural communities buying tritium cartridges the way we now swap propane tanks, except these cartridges started life as spent fuel rods nobody wanted. Your turn to weigh in. Is turning nuclear waste into fusion fuel a brilliant hack or a risky gamble? Could this approach finally crack the fusion fuel crisis? Or should we pour every dollar into wind, solar, and batteries instead? Drop your hot takes below. Agree, disagree, or roast the idea entirely. The debate is just getting started, and your comment might shape the next headline. One thing's certain, the era of waste not, want not is about to get a nuclear upgrade.